Good evening, friends. Sorry for the delay. Let's start with the interview preparation. Okay, let's start with the first question. List down some of the metrics used for evaluating the regression models. What are the metrics you are going to use for evaluating the regression models? I will be giving you some time. Please respond in the chat window. 2 minutes. Please respond in the chat window, guys. What are the regression metrics? What are the evaluation metrics that are used for regression model? Am I audible? Can you please confirm in the chat window? Yeah, Ipsita, you are correct. Uh, for the regression models, we will be using these all are the evaluation metrics that we are going to use for evaluating the regression models. Okay, first that is mean absolute error, mean squared error, root mean squared error, R square and adjusted R square. What is the formula for mean absolute error, guys? Please respond in the chat window. What is the formula for uh, mean absolute error? Let's go one by one. Yeah, Ipsita, it's not about my, oh, once again, my this it's not working. Pen. Sorry. Okay, let me tell you directly because my pen is not working. Mean absolute error. Mean absolute error. Uh, it is a difference between actual means absolute value, whatever the actual value minus predicted value divided by average means a number of calculated 1 by n into summation of actual minus predicted, where I runs from 1 to n means for all the individual rows. That is the mean absolute error. What about the mean squared error? Mean squared error. Uh, okay. I will means here mean absolute error is uh, today I think some issue with this presentation. I am not getting this pen to draw. That's what. Okay, let me explain like that only. Okay, mean absolute error. Mean absolute error, it is a difference between the absolute value and the predicted value divided by number of points. Here, mean squared error. What is the mean squared error? Mean squared error is the difference between actual minus predicted whole square divided by number of rows or number of samples whatever we have. That is the mean square error. What is the root mean squared error? Root mean square is nothing but square root of sum of all the points of actual minus predicted whole square divided by n. That is the root mean squared error. What is r squared? R square is nothing but 1 minus SAC, sum squared error divided by TSE, total sum squared error. What does it mean? A formula, if you go into SSE deeply, 1 minus y minus y hat. Y hat is predicted one whole square divided by y minus y mean average of that individual column whole square. That is what the r square value. Then what is adjusted r square? Adjusted r square is an extension of an r square, extension of an r squared, where see if you have some value, if you have some value in the means if you are adding one more data point, means not a data point, one more feature into your data set. If you add one more feature into the data set, the r square value usually increases because of the variance in the data. Even if the data, whatever the feature you have added, even it might, if it is not related to giving the output, the way, because of change in the variance, r squared value increases, but r square value should not increase. For that sake, we are using a adjusted r square value. Here, adjusted r square value, what it does here, even though if the data feature, new feature, whatever you are added, if it is not related to the algorithm, or not giving an output, means it is not the feature which independent feature which does not depends on the dependent variable, means dependent variable is not depending on that feature. If that type of data feature is added, adjusted r square value doesn't increases, but r square value increases. This is a major difference. This is so adjusted r square is an extension of an r square value. Okay, let's go to the next question. What is confusion matrix? First of all, do we use confusion matrix for regression or classification problem? Please respond in the chat window, guys. Yeah, 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 Ashwini, that's correct. We are using confusion matrix for classification. Then what is confusion matrix? What is confusion matrix? Please respond in chat window. Yeah, Shalini, it is used for classification. Then what is confusion matrix? Yeah, okay, let's go to the so what is confusion matrix. Confusion matrix is a table. It's just a table here. Whatever you see, it is just a table which describe the performance. How actually means whatever the model we are trained using the classification model. It here it is a matrix which tells the performance of a classification model on the test data set. Means whatever your model you are trained for train data, and if you are checking the performance of it on the test data, it it is based on the test data. The true values are known here. What happens in it decision matrix, which gives how actually it is performing for the test data. In that one, in the confusion matrix, you will be having the four major four things you should be knowing. What is this? True positive. True positive means actually it is a positive, and it is also predicted as a positive. Means for example, let's take an Gmail. If you are getting ham and spam mails, it is an ham mail and it is predicted as an ham, then it is a true positive. uh, this is actually ham and it is predicted as an ham, then it is a true positive here. And false negative, what is false negative? Actually it is an ham but it is predicted as a spam, then it is a false negative. uh, then false positive, actually it is not, it is a spam but it is predicted as ham, then it is an uh, false positive. What is true negative? It is a spam and it is predicted as a spam, then it is called as, then it is called as true negative. Negative, it is correctly identified spam. This is the matrix, confusion matrix. Okay, then once you had find out the confusion matrix, how you are doing, means what is the precision, accuracy, what is precision? Okay, first let's go with an accuracy. What is an accuracy? Before going to all those things, let's see what is an accuracy, guys. Please respond in the chat window. What is an accuracy? uh, by looking into this table you can give me the formula. You can tell me the formula. Yeah, Shalini. Accuracy tells about the how correctly the model has performed. Here, accuracy, if you look into this table, based on this table, if you want to tell, accuracy is true positive plus true negative. These are correctly predicted. That are comes under numerator. True positive plus true negative, these are correctly predicted, divided by total number of the things, means total is a sum of all these things. True positive plus true positive, true negative plus false negative, false positive, all the sum will be at the denominator. That gives the accuracy. Then now let's talk about the individual, means that is accuracy. But what are precision? What is precision and what is recall? What is F1 score? Accuracy tells about the how accurate the model is working. But what is precision and what is recall? Why precision and recall comes into picture? Yeah, Paresh, you are correct about the accuracy. Now, what is precision and recall? I will be giving you 2 more minutes to respond, guys. Uh, Okay, let me tell you what the precision actually is. Precision is nothing but precision is nothing but out of predicted positively predicted values, how many of them are correctly predicted. How, what the precision tells? Precision tells about out of predicted elements, means out of positively predicted elements, how many of them are correctly predicted. If you see here, if you go here, out of uh, here, this is which it has predicted properly. If you see this precision formula is which are predicted correctly divided by total it has predicted as an whatever the things it has predicted as and precision tells you total number of correctly classified elements out of predicted elements, whatever it has predicted as an I told you the example of ham and spam, right? In that one, if the model has predicted, if you think the model has predicted 300 of 300 as ham. In that 300 ham, actually, how many of them are ham messages? If, for example, if it has predicted 300 300 as ham, in that only 200 250 are actually ham, then that is what the precision is. Am I clear? Am I clear about the precision? Are you clear, guys? What does the recall tells then? Recall tells it is the what the recall tells means it is the ratio of total number of correctly classified. What it has correctly classified means I told 300 by 250, right? There here 250 is the correctly predicted ham messages. But out of what? Out of actually which are ham. Actually which are ham means it is not what about, it's not telling about what it has predicted as ham. It is total ham, whatever the total ham we have means actually if I tell you example something like actually I have 350, I have 350 ham messages, but the model what it had done, it had predicted to 300 as ham messages, but in that 300 only 250 are ham messages. So now recall is telling what the recall is telling about uh, what the predicted hams in that which are actually ham divided by total hams means original actual hams are there, right? That one is a recall. Then based on this, this is what the recall tells about. What is then F1 score? Why we should use F1 score? Will we using the F1 score everywhere? Okay, F1 score is twice the product of recall plus precision divided by recall plus precision. Why we are using F1 score? If we come to know, if we are thinking about why we are using F1 score, here some problems. See, if you are predicting some problem, means here in that one only the precision, only if you are thinking about precision is telling about how many of them are correctly, means out of predicted one how many of them are correctly predicted you are knowing. But recall in the total whatever the actual are there, in that how many it has predicted, you are getting the two things, but you are not getting the whole about the model. Means you are not getting out of predicted one and also actually predicted, both the things you need. For that case you will be using F1 score. F1 score here formula is twice the precision into recall divided by precision plus recall, and the final whatever the output you are getting F1 score, if you are getting good F1 score means yeah, if you have good F1 score means it will be ranging from 0 to 1. If you are nearer to 1, then it model is working fine, it's very good model. Okay, am I clear? Okay, next question. What is an imbalanced data set? What is an imbalanced result? I will be giving you 2 minutes for responding in chat window. No, no, no. It's not about Paresh. It's not about normal distributed. What is an imbalanced data set? When we call the data set as an imbalanced one. Okay, fine. Imbalanced data set is nothing but if you have a two class means you can think you have a two class problem. If you have a two class problem, something like whether the person will pay the loan, default the loan, or he is going to pay the loan. If the classes, whatever the classes we have means default and not defaulting the loan, if they are equally balanced like 50% 50% or something like 60/40, if it is something like that, it is a balanced data set. When we call the data set is balanced, minimum 70/30, minimum is 60/40, or like that 40/60, like this proportion can be accepted. This may be called as a balanced data set. But if one data set is one type of class data is more, means for example only 10% of the loans are 10% of the loans are defaulted and 90% of the loans are not defaulted, then that kind of data set can be called as an imbalanced data set. See here, what if you can see the definition, if you can see the definition, the data set which is with an unequal class distribution. Unequal means it is not equally distributed, means not almost not equally distributed. In technique, it is called as imbalanced data set. It is said to be imbalanced when there is a significant and some extreme cases, means some extreme cases, that's what I said. 90% of the data set is not default and 10% of them are defaulted the loans. Otherwise, if you can take any cancer patient's prediction of whether the cancer is there or not, there might be whether he's suffering from prediction. If you take thousands of the patients, only that if, only maximum of 20 no, 130% of the cases will be predicted as a cancer, and others are non-cancerous. You have that kind of data set, then this kind of data set is can be called as an imbalanced data set. If you have an imbalanced data set, how we will be solving? Yeah, see, data set is normally distribution is different, and this is imbalanced data set is different. Normally distributed is bell curve, the data set which is following the normally distributed means bell curve, that is different. But this one here, the data set is not following normal distribution. Here data set itself, one class output variable, if you going with an output variable, there normally distribution you are checking with the whole data. But here imbalanced data set, you are checking with the classes, how the classes are distributed, whether they are distributed yeah, means if it is 70/30, it is okay. Maximum we will be considered while training the model 70/30 is also okay. 70/30 or 60/40 or 50/50, this is okay. But if it is extreme means 10% and 90%, then what happens when you are when you are training the model, your data means your results, whatever the results you are getting, they will be biased towards the class which is having high values. Means 90%, if you have not defaulted, then the whatever you are predicting, there will be a chances of giving the biased result towards the not defaulting the loans. That's what we tell about the imbalanced data set, Paresh. Okay, I think you are clear, Paresh, now. What is upsampling and downsampling? What is upsampling and what is downsampling? I will be giving you 2 more minutes to respond, guys. Okay. Upsampling. What is the upsampling means? The process of here what we will be doing the here I said there cancer patients only if you take 100 out of 100 only 10% of them are suffering from means predicted means they have cancer means that we have a data set where the data set having 90% non-cancerous and 10% cancerous. In order to make the data balanced, we will be doing upsampling and downsampling. Here, what sampling we can do to increase the this one means we have only 10% of not having cancerous, right? There, in order to we will be duplicating which is having cancer means 10% values we will be duplicating such that it will be equal to the values which are equal to the means there 90% is there, you have only 10 here. So what you will be doing, if you have 90 samples of you have 90 sample of non-cancerous and only 10 rows of this one what which is having cancerous. Now you will be duplicating this 10 rows 9 times, then it will be what happens 90-90 means 90-90. If it becomes 90-90, it is 50-50% are there. So now that becomes balanced data set. You can increase the you are duplicating the observations of minor classes means I said right 10% which are there which are we are duplicating the minor classes so that we are equating it into the major classes so that data becomes balanced. When we will be doing upsampling means if we have 100 we have only 100. If you reduce the means here if you are duplicating, the data size will be increased. When you have small size of data set, you have the size of the data set is small, then you will be going with upsampling. When you will be going downsampling we will be going when the data set is huge. Even if we reduce, even we lost some data, if we are that's what we you will be sampling, you are randomly duplicating those only. Here downsampling, in downsampling what you will be doing, you will be removing the observations, because here if you have a huge data set, here what you will be doing, you will be removing the observations from major means 90-10 I told right. In that one from the 90 class majority class, from that majority class we will be removing the observations so that we make those two into balanced means by removing, if we have 90 and 10, probably we might be removing 80 or we will be removing 80 or 75 something like that so that our data sets become balanced. If you are from 100, if you are decreasing, what happens, sample size, overall sample size, what it happens, 10 20 total sample total what it happens, it becomes 20, right? Now the data set size reduced. So when we have a data set, huge data set, then we can go with downsampling. If you have a less data set, small size data set, we will be going with upsampling. I'm clear? If I'm clear, okay, please respond in the chat window. uh, Next question, what is NLP? Yeah, natural language processing. Okay, NLP is a field. It is NLP. Its full form of NLP is natural language processing. But what we is what's the definition? Definition. If you go with the definition, NLP is an subfield which deals with linguistics, means language based on language based. By using computer science and artificial intelligence, we will be interacting interaction between the computer and human computer between the interaction between the computer and human using this artificial intelligence. And this process of analyzing the process of analyzing what we are analyzing, linguistic data or natural language data, whatever we can call. If we are analyzing the language, natural language data, then that is called as NLP, natural language processing. Okay. uh, what do you mean by tokenization? Yeah. Okay. Let me tell you what the tokenization means. Tokenization is nothing but splitting the string, whatever the string you have, splitting the breaking or splitting or whatever we can say breaking the string into pieces of words, individual words or phrases. Means like if we have this sentence, if we are splitting or breaking this sentence into the cat individual words based on phrases or symbols, based on symbols or keywords. If you are splitting them, then it is called as tokenization. The process is called as tokenization. Individual word, whatever the individual word is there, right? Individual word. This word is called as token. Individual word. Uh, Ashwin, it's not the removing prefixes. It's about the splitting the string into individual token. Yeah, means individual word or by splitting into a symbol or phrases. Then it is called as tokenization. Process is called as tokenization. Individual word is called as token. Okay. Now, what do you mean by stemming? Okay. Stemming. What does the stemming means? Yeah, Paresh, you are correct. Stemming is nothing but stemming is nothing but if you have a word, if you are removing suffixes, whatever comes after the word, suffixes, something like ing, ed, s, these are suffixes, whatever you are attaching ing, ed, s, and all these things. If you are removing the suffixes and you are not taking and you are removing that and you are coming up with then some word, then this process is called as stemming. But yeah, see, if you have connect, it will be giving connect, but if you have connected, it will be removed ed and it will be giving connect. If you have connection ing, it is removing and it will be giving connect. Here it is removing suffixes whatever it is having, but it doesn't look into the meaning whether after removing the suffix, whether the word, previous word whatever it is having, and the final word after doing suffix, it doesn't check whether the both the meanings are similar. Then this process is called as stemming. Then what is lemmatization? What is lemmatization? What is the difference between stemming and lemmatization? Yeah, Ashwini. Okay. Lemmatization is nothing but, see, whatever you are doing in stemming, you are removing the suffix. You are removing the suffix, but you are not checking into the dictionary meaning. If you are not checking into the dictionary meaning, whether after yes, removing the suffix, whether it is giving the same meaning or not, whether it is giving same meaning or not, you are not checking, then that is called as stemming. If you are checking the meaning, it will check the meaning whether after removing the suffix whether it gives the same meaning. If it gives same meaning, it does the removes the suffix. And even not only about the removing that suffix and gives the same word, it's not only that, better, even better, if you do lemmatization, it will be giving good. Better and good both gives the same meaning. If this type means it checks for the dictionary value, and if the grouping of different means even the different words which are having the same meaning, it will be giving, means considering into a same word. This process is called as lemmatization. Here what it's following, it's checking with the dictionary meaning, but here stemming, it just removing the suffix. Here you can see abl, abley, it doesn't checking. See, airliner is there, but it is removing air, airline. Does it gives any meaning here? After removing, it doesn't gives any meaning, but here it's stemming, it doesn't remove. It remove directly, it checks whether after removing whether it's giving meaningful things, and it groups the words which are having the same meaning. This is called as lemmatization. Okay, what is bag of words? Okay. Here, okay, let's go. What is a bag of words means? Bag of words means nothing but extracting the features from the text document. Whatever the document you have, from that it extracts individual text. And for training in the machine learning algorithm, you have to assign means you have whatever you want to extract the features from the text, and that should be used for training the model. We can't use this text directly to train the model, so we are assigning numeric means we are assigning the converting into numeric form. How what we will be doing here? Here, bag of words gives the frequency of the word which is coming in that particular document. What is document? Document means if you have this whole paragraph, if you see this, I have here it has whole paragraph. This whole paragraph, if you have this, might be called as corpus. This might be called as corpus, and from here to first full stop. Okay, this one. Uh, Here to here. Bag of words is a method of extracting features from text documents. This is called as one document. One sentence is called as document. In that one, individual token. Individual token. What is the individual token? Individual word. Bag is an individual token. Of is an one token. Words is an one token. Like this. What the individual token? What it will do? It will be creating a table. It will create a table, keeping in the columns, it will be keeping all the words which are coming in that document, and it will be labeling as one means see here you have four sentences, right? The red dog, cat eats dog. Here what happens for the first sentence, second sentence, all these words will be in columns, and this 1 2 3 4, these are documents, this will be in the rows. Here the red dog in the first row, what will be doing, below the column, it will be mentioning as one. In the red it will be mentioning one. Dog, below dog, it will be mentioning one. And remaining other words, cat eats, there it will be mentioning 0 0. All the other, for other words, it will be mentioning as 0. Like that, it will be forming. This is called as bag of words. Here what it is giving, it will be giving the frequency of an individual term in the document. Okay, this is what the bag of words means. What is TF-IDF then? What is TF-IDF? Why we use TF-IDF? Yeah, Paresh. TF-IDF is term frequency inverse document frequency. It is a full form expansion. What actually it means? Yeah, Suresh, you are correct. TF-IDF TF-IDF is nothing but term frequency inverse document frequency. Its full form is, here what it gives the weightage, importance for a particular word. Not here what the bag of words giving, it giving the frequency of a word inside the document. But here it is not like that. It gives the weightage, importance for that particular word over throughout the document. Here, what it is, TF-IDF is a product of term frequency and inverse document frequency. What does the term frequency means? Term frequency means number of times the word, whatever the word means. If you consider this as a one document from here to here, it to document, individual word, it is there, it how many times it is coming in that document? One divided by total number of terms in that document. 1 2 3 4 5 6 7 8 9, 10, 11, 12, 13, 14. 1 by 14 is the TF of the it. That is the term frequency of that token in that document. That is term frequency. What is inverse document frequency? Inverse document frequency tells about, it's a log of total number of documents. Means here, if you take this whole corpus, if you take this as a corpus, how many documents are there? This is one document, and this is two documents, and three. We have three documents. In that three documents, total number of documents divided by number of documents with term t. 3 divided by how many documents it is there. Here also it is there, here also it is there, but here I think in third document it is doesn't have. Then it is 3 by 2. That is 3 by 2, log of 3 by 2. That is inverse document frequency. What is TF-IDF? TF-IDF is product of term frequency and inverse document. See, it is giving weightage to that word by checking not only about that document, but overall documents among the corpus. It checks the weightage of that individual token. That is what the TF-IDF gives. Am I clear? Okay, please respond in the chat, Thank you for attending interview preparation session. Thank you all. I'm ending the session, guys.